All right. Okay, so I'm going to work on the program first, and just have to find a good size to do it, so that we can see both the instruction and also the text box that I will be using to write the program. I think this would be good. There we go. Okay. So I want the program to read and process a line until a line only contains the word quit is encountered. So the sentence implies that this is going to be a loop. Otherwise, I would not be using the word until. Okay. So let's go ahead and write the subroutine. Okay. So we'll start with just main. I will change the program as necessary. Okay. So this is my main program. This is supposed to be a loop until we find the word quit all by itself. So in this case, I can't really determine whether to quit or not until I have read at least one line. Okay, so that means well, there are several ways to do it. I'm going to do it the long way first, and then we'll see whether there's a quicker way to do it. So if I have to do the body of the loop first before we can determine whether to quit or not, this will be the right construct. This is a post-checking loop, so that whatever I put between line 4 and line 5 has to be done first, and then I will evaluate the condition that I will specify on line 6. Okay. Are there any questions at this point about this part? Okay. Now, since I do want to use a line only containing the word quit as the indication to get out of the loop, so what I'll do is I'm going to use an array here, and we'll just say this is a buffer. And with buffer, I have to allocate 81 character and not 80. The reason why I need 80 characters is because the first item, I'll show you exactly where. Each line may have any number of characters, only read up to and process up to 80 characters of the line. If you want to represent 80 characters using a string in C, you need to allocate 81 characters because the null terminator takes up 1 byte as well. So that's why buffer needs at least 81 characters. If you make it longer, it would just be wasting memory, but it's not going to hurt. Okay, so the first thing we need to do is to find out, okay, how do I read a line from standard input into buffer? And that's a part of the previous lecture or previous lectures. Using the getLine method is the way to do it. So what we'll do is we'll do a std. Okay, now we have to do the pound include. So pound include iostream, and once we do that, we can do std cin .getLine. GetLine actually has two forms. One has 3 parameters, one has 2 parameters. I talked about the one that uses 3 parameters, so I'm going to stick with that one. So the first thing we'll do is we'll specify the address of the array that will store up to 80 characters, and that's going to be buffer. The second parameter specifies how many characters I want to read from standard in. I can just hard code it here, which is not a good idea, but nonetheless, for this program, it is probably okay. So I'm going to hard code it to 80 characters. So I'm going to read up to 80 characters on the line from standard in into buffer. And then the last parameter specifies what I will consider as a new line or the end of a line. And the carriage return is usually translated to the new line or the line feed character, and that's the way you specify, how or when it will stop reading as one quote-unquote one line. And after that, I'm going to test here and say, okay, is it time to quit? I talked about string compare, and you can certainly use string compare to quit, okay? But even without knowing that, you can still check for QUIT and a null terminator in buffer. So that's going to be the way I do it here, just to spell out the QUIT. So it's going to be Q buffer bracket 0 equals the ASCII code of Q, and buffer bracket 1 equals U. You get the idea. Pretty sure I talked about this one in class. And then the I, and buffer bracket 3 is T, and there's one more. Okay, forgot the open paren here. There's one more because I have to make sure that it is quit and not quitting or something like that. So that's why I have to check the fifth element, which is at index 4, to the null terminator. Now if I don't do that, okay, if I don't check buffer bracket 4 is 0, then it may be quitting, Q-U-I-T-T-I-N-G, and the program will still quit, but that would not be the right time to quit. This makes sure that quit Q-U-I-T is the only word on that line. There's nothing else on that line. Okay? Yep.
I had an issue with that because the last class you're telling us that the end operator \n would be the terminator, and so I kept putting that in the quotation marks, and that wasn't working, but it took me a while to figure that out, that it's a 0.
Which part?
The last part, buffer 4. It was just unclear from the last lecture that the 0 was the ending, but not the enter key, which is the /n.
The enter key is used to indicate the end of a line, but in order to end a string, as a string in C, you always use the null terminator. Okay. All right. So just the way it is right now, I'm going to test the program. Okay. I'm not going to go any further than this. Okay, because I want to make sure that 1, it will read it line by line, and 2, this is the right way to compare and locate the quitting condition, okay, which is going to answer your question. Okay, so if I have any doubt, okay, of how to end this program, this is what I would do. And obviously, to make the compiler not to complain about not having a return value, I just put a return 0 at the end here. So this program is not quite done yet. Okay, I'm just putting something in it, but it is enough for me to actually compile and check it already. So I'm going to turn on all the warnings, pedantic, with all the debug information, which is -G, -O to specify the output executable, and you can name your executable any way you want to. I don't really need to know or control that. But the source code has to be main.cpp, and hopefully I didn't make any stupid mistake. Doesn't look like I make any syntax stupid mistake, but logically I can still be making some stupid mistake here. And to test a program like this, you will need to have some really long lines, and so it makes sense to use a test input file so that you don't have to retype all the test cases every single time. So this is what I'll do here, is to have a test case 1, and this is the entire file. Now, this one as a file is an empty file, okay? It should still work. I take it back, no, this one should not work because it needs to have at least one word quit in order to test it, because I did not specify that your program has to check for empty input, so I'm not going to test it for empty input. Okay, so every file will have to end with QUIT, so that way if you check for quit, it will always end properly. Okay. Here's test file number 2. And for test file number 2, I have an empty line and then a single quit. So the first line has nothing in it, just the line feed character. Test file 3, I can have one single character, like A, and then the second line is just quit. And then test file number 4, I can start to have a long sentence here. Now instead of making a long sentence that is just gibberish, I'm going to specify a pattern that goes in one direction, because that makes it easier for me to test whether the reversing is working correctly or not. So I'm going to do a yank here, and I think that's more than 80 characters. Oh, that's not pasted correctly. The 9 is not done in the right place. Okay. Now it's right. So 3, 4, 5, 6, 7, 8, 9. Okay, that's more than 80 characters. Yeah, why not make it some more? And then the second line is just quit. So every single one of these cases has only one line and then the quit word. And then we can give it something that has multiple lines, but that's not difficult to specify because the source file of this program fits that description without the quit at the end. So we'll test these 4 first, okay? If it does work for these 4 test files, then we'll go ahead and test a little bit more. So now we go into GDB with the main executable. And I'm not going to try anything that is too tricky first, okay? I'm going to try test 4. Okay, test 4 has the one line that is way too long, but that turns out to be not a very tricky case because it does fill up all the 80 characters, or it should fill up all 80 characters. So I'm going to run the program, but when I run the program, I'm going to run it with a redirection, which means I'm going to take the input from test4.in, so this way I don't have to type everything, when I'm testing the program. But before that, I have to set up some breakpoints, okay? So an important breakpoint that I have to set up is on line 10. So every time I get to line 10, I want the program to stop, so I have a chance to examine the content in buffer, just to see what I have been reading it. Okay, now I can actually run the program with test4.in, and this is the first time we get to line 10. One thing you can do is to just print buffer. And you can see that in this case, when we do a print buffer, it goes all the way to read only up to the 8 here. Okay, the line feed character, 9 is supposed to be here, and that's because when I specify read up to 80 characters, it will no terminate at the 80th character, so it will only read up to 79 characters. That's one thing I have to fix. Okay. Let's continue execution, because I still want to check, if I just type quit on the line, what is it going to come back as, and whether the logic to check for quit is going to work or not. So I do a continue, and it exited right away, which means the while loop is false and it gets out. So the polarity of the checking of QUIT is opposite to what I want. Because in this case, if I type quit, it will continue. If I type anything other than quit, it will exit the loop, which is not what I want. Okay? All right. So I did make a few mistakes in the program. The first problem is easy to fix because I just have to say, oh, you know what? Buffer itself has 81 characters allocated. Okay, so this way it will read up to 80 characters plus the null terminator at the end, using up all 81 characters in buffer. The second problem is also easy to fix because I can just now say, let's take the negation of all of this stuff here. Oops. So put a negation at the very beginning, and then add one more level of parentheses, and now it is negated. So while not QUIT and the null terminator, go back and do it all over again. Are there any questions about this process? How to debug a program and not to write too many lines of code before you do it? How many people kind of do it this way? Make it very simple, test it first. They're not working the way it's supposed to, fix it. Okay. In the long run, it's not going to be a waste of your time. Okay. If you do it very slowly, step by step, it just makes debugging a whole lot easier. All right. So now that we have this part done, we'll go ahead and recompile the program and then run it again. So we'll do a GDB main, put a breakpoint on line 10 again, do a run from test4.in. Same thing, go ahead and print what is in buffer, and this time it is done correctly because this time it read 80 characters. Now I specifically use 0 to 9 as a pattern because now I just have to count the number of zeros to identify how many times it has repeated itself. We got 1, 2, 3, 4, 5, 6, 7, exactly 8. And each time 0 appears, if it prints all the way up to 9, there'll be 10 characters. And 10 times 8 is 80, so this is reading correctly because the input file has more than 80 characters. All right? And then we do a single step because it is not supposed to quit, right? This is not QUIT. Single step, and it goes back to the do loop, which is correct because I reversed the polarity of the condition. And I just press continue. It will read the next line in. It will stop on line 10 again. Print buffer. And you can see that this time, buffer is a null. and that has to do with it's reading get line again. It's using get line again, and it's not getting past the no terminator. Okay. All right. So it's not getting past the new line character in get line.
Can you pull up the source code?
Yes. This is the source code, this is the while loop, and get line is here. Hmm? Do we have to clear that?
Mine works properly.
Yep.
I actually forgot to do the loop, keep on looping.
Mm-hmm.
So I never encountered that problem. First time seeing something like that.
It's working fine.
All right. So if it doesn't work, I'm gonna use.
Actually,
Yep.
oh, when I changed it to one.
Thing going to make it work,
Look.
you would do that.
So okay.
Did it seem clear?
I found the problem. When we had 80
Mm-hmm.
within the buffer and in a get line, it's
It
working
will set
okay.
the fail bit.
And so when we added one, it's
Mhm.
crashing right away.
Well, I think in this case it's because the fail bit is set, and the fail bit is set is in this case because the delimiting character, which is this one here, which is our line view character, is not found once of the characters that we have read up to 80 characters. So when the input line is too long, it's gonna complain. Okay, but since I didn't talk about this in class, that test case will not be used for grading purposes. So you guys are safe if you cannot handle that test case. But now that we know this, I'm going to change my program to account for that. So fail bit is the same thing when we try to read from a file, to look for an integer, and it doesn't find anything that can be the beginning of an integer. So clear will also clear this particular error. All right. So I'm gonna test it again, but I'll change the program first. .cpp. And the lazy way to do it is to do a stdin.clear every single time, whether I have a problem or not. I'm gonna clear it. So recompile. GDB main. Put a breakpoint on line 11. Run the program with test4 again as the test input. Might as well use the same one to test it again. Print buffer. Okay, that part is right. Go back to the do. Continue one more time. Print buffer. And it's reading the remaining of that line. So in other words, it cannot clear the line, after the first read. It's reading the rest of that line. And we'll continue again. This time it will be quit because this is the next line. Okay, so here's quit. This is the first thing this is the only thing that I wanted to test, but it turned out that we encountered some of the other problems. So it does spell out QUIT and a null terminator, okay? And you can also print the individual elements of the array. So we have buffer 0 as Q, 1 as U, and so on. So this is a really useful tool because with GDB I can examine the content in the buffer, and that really helps me understand, okay, is this logic going to work to identify the word quit in order to stop the loop? We still doing okay so far? Yep.
I just changed it to 80 and then ran it.
Mm-hmm.
Okay, it worked. Then I switched it back to 81 and then it worked. I didn't use clear or anything, so I don't know why why.
Did you give it a line that is too long?
Not yet.
Yeah, you have to give it a line that is too long. If it's not too long, it won't trigger the fail bit, and
It just froze.
All right. Okay, but I'm not gonna test your program for exceeding 80 characters, but I will give it something up to 80 characters. Okay. All right. So now I can give it actually something to test for the reversing. So I'll call this test5.in, and we'll just give it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and quit. Otherwise, it won't be able to quit. And we'll test it again. Run the same program using the new test case. So put a breakpoint on line 11 again. Run, but this time use test5.in as my test code or my test case, and print buffer. And this time it is correct because it will require less than 81 characters to represent 0 to 9, so it reads it correctly. This is the first iteration, and the second iteration is going to give me QUIT, and that's also done correctly. So at least at this point, I know the framework of the program is working. It is reading line repeatedly correctly, and it's also looking for the word quit, because if I continue here, the program will quit because it just found the word QUIT with a null terminator right after that. So are there any questions about this part? No questions? All right. So at this point, I can go back in and continue to change the program, because this is not even the main part of the program. The main part of the program is string reverse. String reverse, according to the assignment description here, is it has to reverse all characters on the line and print that line to the standard output file. But you are required to implement the logic in the subroutine itself. So you have to implement string reverse using these particular parameters, and I'm just going to be a little bit lazy and copy and paste it into my program. So this is my prototype, but I'll turn my prototype into the actual function definition. The first thing I want to do is to see if I can just copy everything and not reverse it, okay? Because the reversing part is a little bit harder. If I just want to copy from original to quote-unquote reverse, I just want to see if that works first. And how would you do that? Do you guys still remember string copy?
Yeah.
Okay, so we'll go ahead and do something like string copy first, okay, just as a practice. To do string copy, we can terminate as soon as we see a null terminator, or when we encounter, when we have already worked up to n characters. So we'll go ahead and do it this way. So the way to do this is, there are several ways to do it. I need a local variable that is I, because I don't want to use pointer arithmetic. Remember, you have to use array indexing all the time, so that's why I need I as an array index. And I is initialized to 0, so I start from the beginning. And then what I do is I will scan forward, and as I scan forward, I will also do the copying to the destination. So I can now say, while the first one is n minus minus. Okay. In other words, I'm saying as long as n is non-zero, I'll do a decrement and and prepare for the next round. So this is actually counting the number of characters that I'm copying. And then I will specify the additional conditions. The additional condition is original bracket I, which is the character at index I of the original string. And I can just do it this way without the comparison to a null terminator, because just doing it like this means that if original bracket I is a non-null character, it will be true already as a statement. So now we have true and true as a condition. So this is, this will work. But if you wanted to spell out and make it easier to read, you can certainly do this here to basically say if the character is not a null character, then go ahead and perform whatever the body of the loop is going to do. And obviously, if you don't like using auto decrement, you can also say if n is greater than 0. Okay, that makes sense too. So there are many ways to express the same logic in C in this particular case. But if I get into here, what does it mean? If I get to line 9, what condition must be true?
Line 7 must be true.
The condition on line 7 must be true, and because I'm not using any post increment or pre-decrement or anything tricky like that, it means literally the condition of line 7 has to be true because I don't have any side effect on n or I in this case. So that means n has to be greater than 0, which means I have more characters available in the destination, which I call reversed in this case. And also, in the original string, I'm not encountering the null terminator just yet. Yep.
Since you're using the and logic only one side, only the left side has to be true, right?
Only
The left side, the n greater than 0. For the whole statement to be true, only the left side has to be true, right?
no, but they both have to be true because this is a conjunction. Because I'm using the conjunction here, ampersand, ampersand, that means if n is greater than 0, I have to check the other one too. Because with a conjunction, if any side is false, it makes the entire thing false. So that's why in this case it will check for both. Okay. So what I want to do inside, the first thing is I want to decrement n by 1, okay, because I have used up one more space, and then I just do the copying, which is reversed bracket I gets original bracket I, and then I do an I plus equal to 1 or I plus plus, either way is fine, so that I'm now ready for the next character. Is that okay? All right. So after this, after I get out of this loop, now how can I get out of this loop? If I get out of this loop, what condition must be true?
Both.
It should meet
No,
the
I'm out of the loop already.
All of them should be true. Or one of them should be false.
At least one of them has to be false. They can both be false at the same time, but one of them has, at least one has to be false. So when I get out of this loop, n is greater than 0 may be false, okay, but it may not be, because if n is still greater than 0, I still have a second chance of making the conjunction false, which means original I is already reaching the null character. Okay, so depending on which one is the case, I might have a different thing to do. There are several ways to look at this. One way to look at this is to say, if I still have, yep, go ahead.
I plus equals 1 is the same as I equals I plus 1?
Yes.
Okay.
Yep. So one way to look at this is to say, if I still have more space at the destination, I'll just fill it up with null characters. Okay, because never hurts to fill it up with null characters. So I can now say, reversed. I cannot spell reversed. Bracket I gets a null character, and then I plus equal to 1. So I'm just filling up, the rest of the destination string with a null character. Okay, so that's how this works. And I'm now getting back to my program here. And what I want to do is to say, let's declare a local buffer. I'll just call that, output buffer. And I'll make it the same size as the original one, which has 81 characters. And then what I'll do is after I do the get line in the clear, I'm going to call my own subroutine, which is string reverse. And I'll pass output buffer as my destination string, buffer as my original string, and I'll specify 81 characters, copy up to 81 characters, okay, including the null terminator, copy up to 81 characters. But the program is not going to print anything in this case. There are two ways to debug this program. I can use a cout if I want to. I can also just use GDB on line 30 in this case, make it print what is in output buffer, and that would be one way to debug the program. Because cout is really just printing whatever is in output buffer, so it's not really any better than using GDB to debug this program. How many people got gibberish printing after the intended the portion that it's supposed to have? Okay, so how did you debug your program?
I just kind of gave up and closed 16 last night.
Okay, but if you encounter problems like that, you can use GDB to debug it. Because what you do is you print out the entire buffer, and then you figure out, okay, what am I missing here? And I'll artificially introduce that problem here, just so that we can see that problem, and then in GDB, what does it look like, and then we'll try to figure out a way we'll fix the problem. Yep.
Shouldn't clear be fixing that?
Say again?
Shouldn't the cin.clear be fixing that?
Be fixing.
The extra junk that's
No, because cin is really just clearing the fact that we did not have enough space to store the previous get line. That's what it's clearing, but it doesn't do any. It doesn't do a single thing to buffer itself. Okay. All right. So I'm going to introduce a problem, artificially putting the problem in, and just say that, okay, let's say I forgot about this part here. So I'm commenting out this section of the code, which means the string that I copy is not going to be null terminated. Okay. So this should give me some problem. Okay. I'm hoping it will give me some problem. You don't hear that very often. Okay, so we'll put a breakpoint on line 30, and then we'll use test5.in, which is just 0 to 9 as the input. Yep, go ahead.
One more question. So, when calling str reverse on line 28, does it matter how we're gonna call the input functions, like you wrote output buffer and then buffer for the first comma and then second and 81? Those names are not specified within the program.
Those names, which ones?
Line 28, output buffer.
Output buffer is actually declared here.
Oh, okay. I didn't see that.
Yep, I sneaked it in a little bit. All right, so this is the first time we get to this point here, which means spring reverse should have been called already. So the good thing is spring reverse itself did not crash. It's not an infinite loop, it did not crash. But the question is it doing what it's supposed to do? I know it's not supposed to reverse anything, but I should get the original string back, right? So we'll go ahead and print, okay, let's show you what is in buffer, which is the original buffer. And that one is correct. We have 0 to 9 followed by a single null character. The rest I can ignore, because the standard with C string is anything after the null terminator is not a part of the string. As a result, it can be anything. It doesn't really matter. The second thing I want to do is to print output buffer. Output. Oh, I cannot see that anymore because I'm out of scope. Okay. So to make this program easier to debug, I'm going to put it back in scope, so I can, by the time I get to line 30, I can see what is in output buffer. All right, so let's do this. There we go. Okay, this is the first time. Once again, I look at the input buffer, which is 0 to 9, which is great, with a null terminator. Now I look at the output buffer. Output buffer. And output buffer has an issue. Now the issue is not that I'm not copying the 10 characters correctly. The first 10 characters are copied correctly just fine. But the problem is the null terminator, which is here in the original string, is missing in the destination string. That is the reason why you might be seeing gibberish output from your program, is because it's not terminated by a null character. Are we doing okay so far with that? How many people ran into this one? You're printing some gibberish stuff in. Did you find what the problem was? Was it because of the missing or misplaced null terminator? Yep, that happens often. I write programs like that, all the time too. But the proper tool to use to debug that is GDB, because in GDB it can show you not only that you have gibberish after that, but it can also show you where's the null terminator, because some of these characters may not print at all to the screen, so you won't be able to tell from just using cout where is the position of the null terminator if there is one. Okay? So you have to use GDB to show you all the characters in the array then you can say, oh, okay, where the null terminator is supposed to be, it's something else. Is that okay so far? Hannah? Okay. All right, so now that I know this is a problem, I'm going to go back to my program and say, I wonder why there's no null terminator. There's no null terminator copied to reversed because the loop exits as soon as original bracket I is a null character. So once it exits, it's not going to do any further copying because this code here is the only part that will change reversed. And this means, if I see a null terminator in the original string, I'm getting out already. I'm not copying the null character to the destination. Is that okay? That's the analysis. That explains why I don't have a null terminator. Now, the code on line 13 all the way up to line 17 is going to fix that problem because it fills up the destination with null terminators after the original string ends. So that will basically naturally fix the problem. All right. So far, kind of so good. Okay. Next thing, I want to do the reversing now. Okay. Now this would be a good time to save this program into a different name and then work on the program. After you save the file under a different name, because in case I do anything that will screw up the program, at least I can go back to this one and say, okay, at least I know how to do a copy. Maybe not the reversing part, but just copying, at least I know how to do that. So I'm not going to lose the logic that I have developed up to this point. All right, so do the reversing. How do we do it? Well, let's figure out, how to do it, in a few different ways. I'm going to remove this because I want to show you a common mistake that people do when they are supposed to reverse something, and there's an AND parameter here. I think without the AND parameter, it's actually harder to use the wrong logic to do it, but with the AND here, it is actually easier to use the wrong logic, and I'll show you exactly what I mean by that. Okay, with the AND here, and I would not be surprised, and it's not really a problem when people do something like this. Some people may do it like this. While I is less than n, because I know exactly how many characters I'm supposed to copy into reverse. Let's do this. Okay, so I'm gonna say reverse bracket something gets original something here. I gets I plus 1, and what I'll do here is I'm going to reverse it, right? So the first character of original goes to the last character of reversed, and we already know we're supposed to copy up to n characters into reversed. So n minus 1 becomes the index of the last element in reversed. If I just subtract I from that, that becomes the index of the last one, and it will go, I will go in one direction, n minus 1 minus I will go in the opposite direction, and accomplishing the reversing of all the characters. Okay, that's a fairly easy, common way to look at this problem, at least initially. Okay, but what we'll do is to look at, okay, let's say this is how we did it the first time, and how do we know there's a problem? And if we know there's a problem, how do we fix that problem? Okay, so we'll go ahead and compile the program first, and once again use GDB to run the program. And you can see that I have never used cout yet at this point. Right? There's no cout use whatsoever in this program. And so far, all of the debugging is done by GDB. Okay? Now, if you use code blocks, you're not using GDB directly, but code blocks has similar facilities for you to examine the content in an array, and it will accomplish basically the same thing. All right, so let's go ahead and debug the program. I'm going to put a breakpoint on line 24, which is the same spot as before. It's just it is relocated because we made a string reverse shorter, and then we'll run it with test5.in, which is just 0 to 9. And now we are at line 24. So it should have read 0 to 9 and reversed that string. First thing first, let's go ahead and print what is in buffer. Buffer, which is the input buffer, is still correct. Okay, we have 0 to 9 with a null terminator at this point, And now let's go ahead and check what is in the reverse string, which is output buffer. And you go like, whoa, that's not what we want to print. Because if you print this, using cout, I think this is going to be a happy face. This, I have no idea what it's going to be. And they have open square bracket. This is actually the backspace character, I think. \B stands for the backspace character. So the terminal, what it will do is it will actually go back to the square bracket and overwrite it with another happy face, which is the 004. And so it's not going to look right. Okay, it's not going to look right. So we have a problem here. This is not working. What are we going to do? Can you find the 0 to 9, anywhere in here? I cannot find it. Okay. Well, let's double check and see if I can find it at the end here. Okay. So we'll go ahead and print output buffer, and this time I'm going straight to the end and say, okay, let's look at the end of it. And output this buffer. It's a 0. Okay, that's encouraging. What about 79? It's a 1. 78 is a 2. Hey, I'm finding all my stuff, and they seem to be at the right place because that's exactly what my code is supposed to do. Okay, the first character goes all the way to the end of the output buffer. But when you're printing this as a C string, it's printing all of the other 69 characters before the last 10 characters that we are supposed to print. And that's what we are seeing here is a whole bunch of gibberish before what we're supposed to print. Yep.
On one of your print output buffers,
Mm-hmm.
the long string of characters,
Yep.
at the end 060, before that 61, before that 62,
Mm-hmm.
is that meaningful in some way?
This is the ASCII code of 0. Now,
61 is the actual-
because this is in octo, so if it is in octo, this is the number of ones, this is the number of eights. 6 times 8 is 48, right? And 48 is the ASCII code of 0 as a digit.
So earlier when you printed that out, you said, can you find the string of 0 through 9? I did see that. I didn't realize it was an octo.
Yep.
But I did see the 60, 61, 62,
Right.
67 to 70.
Yep. It switches to octo because it encountered too many characters that are not ASCII, and that's why it switched to octo. And if you look at this one here, I'm not sure whether you guys can spot this one here. It looks like a lowercase p, but with a little stroke, across, the curved part of the p. That's because, for whatever reason, the byte code or the 2 bytes corresponding to that location turned out to match a double byte character, otherwise known as Unicode, and that's why it printed out as a quote-unquote Unicode, output, which is not matching the input either. Okay, but using GDB, at least I was able to tell that the reversing was actually working the way it's supposed to. It's just that because we have to print all of this stuff here first before we get to the string. The part that we want to get to would never be printed because there's a no terminator right before the stuff that I'm supposed to print. In fact, there are multiple no terminators before that, so there's no way I can actually get to it. Now, if you go back and test this program using cout, it won't tell you anything. Okay, so I'm going to change my program by adding a cout, and that's unconditional. I know the program is not supposed to print it unconditionally, but I just want to do it just so that you can see what happens when you use cout as a way to debug the program, because it's not going to work. Okay, so I'm going to run the program using main compile first, and then run main, redirecting test5.in into the program. Okay, and this is the output. It's not, It's printing twice because it's also processing quit. It's also reversing quit, so I have to fix that later. But the most important part is reverse is not working. And if you look at the output of this program, it doesn't even show you 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So you don't even know why it's not printing the content that it's supposed to be reversing. But in GDB, it makes it a little bit more obvious. Oh, okay, I can see the stuff that I want to print is all the way to the end of the string, and before that we have some gibberish and a null terminator, so it's not going to print, the stuff that I'm supposed to print anyway. Is that okay? All right. So if that is the problem, okay, so let me go back into GDB and put a breakpoint on line 25, run the program, redirecting from test5.in. Okay, so we are now back to the same spot here. The main problem is, this is the input, okay? We have 0 to 9 and a null terminator here. And this is the output, which has the content that I want to print all the way to the end with a null terminator here. But the printing process is going from the beginning, and it will terminate as soon as it sees a null terminator, which means it's going to print everything from here to here, and then this particular null terminator will stop everything, and that's the symptom. Okay. So how do we fix this problem? How do we put all of this stuff here to the very beginning and a null terminator after that? Well, there's no easy way to do it. You have to find out how many characters we have to copy first before you determine, where to perform, what end is supposed to be, or where's the place of the last character.
Use size of. Use size of.
Size of is not going to helpful because size of returns the static it returns the number of bytes allocated, but it doesn't really care about the runtime content in those bytes.
String length.
String length can be used, but since I haven't really talked about string length, you're not required to use string length, which is the easy way to do it because you just make a call and it gives you back the number of characters, in the original string. So what I'll do is I'm going to use my own logic to find the end. Or that. Yep. All right. So this code is not working because I'm using the wrong number for this one here. Okay. Otherwise, the reversing part is actually not too bad. All right. So the first thing we have to do is to find the end of the original string. Okay. So let's find out how to do that. I'll keep this logic here, because I think I can reuse a part of it. Okay, not all of it, but some of it I can still reuse. But what I'll do is to find out what is the end of original. Okay, so to do that, I'm going to say, as long as original I, sorry, go ahead.
It's not equal to 0.
Yep, does not equal to 0. But I also want to be safe and make sure that I is still less than n because I don't want to run out of the array and scan portions of memory that I'm not supposed to. All right, and in the loop here, the only reason I can get to line 9 is because both conditions on line 7 are true. In other words, the character that I'm looking at in original is not a null character. And I still have more characters that I can take a look at. Okay, that's when I is less than n. So at this point, I can say I plus equal to 1 to look at the next character, and I keep doing this until one of the conditions become false, or at least one of the two conditions becomes false. Then I get out of the loop. When I get out of the loop, I have to say, well, which condition got me out of the loop? Is it because I saw a null terminator? Or was it because I ran out of stuff to look at? Well, the question is, does it even matter? No, it does not matter at all. Because either way I get out, I at this point on line 11 becomes the number of characters that I need to copy into the destination. Is that okay so far? So what do I need to do at this point? I'm trying to reuse as much code as possible, if you look at line 12, from line 12 to line 16, particularly just line 12 and line 14, what is the row of n? What is the row of n on line 14? Why am I subtracting 1 and then I from n? N is supposed to mark the end of the string, right? So at this point, what do you think actually has the value of n, or at least close to what n is supposed to be, the end of the string? Yep. I at this point is actually having the row of n. So if I do an n equals to I, that will set the end correctly, where it's supposed to end, and then I need to change I to go from the beginning again. Well, there's another way to do it, but this is the more obvious way. Okay, so let's double check and make sure this makes sense, okay? And the way you can check to make sure this makes sense is not to run the program again, but you can kind of mentally go through this code and say, okay, does it make any sense? So let's say the input has only 2 characters and then followed by the null terminator. So we have A, B, and then a 0. From line 7 to line 10, it will go through the A, it will go through the B. By the time I becomes 2, original bracket I will become, will be 0. So not equal to 0 will become false, and I get out of the loop. So that means, I equals to 2 by the time I get to line 11. On line 11, I is 2, so that will make n equals to 2 as well. And then on line 12, I is reset to 0. On line 13, I'm going to copy the 2 characters from original to reversed. So when I is 0, it's going to copy the A to position. Which position is it going to copy to? When I equal to 0, what is n minus 1 minus I? N is 2. 1, okay, is that right? Is the letter A supposed to go to reversed bracket 1? That is correct, okay? And so that means the other one is going to be correct as well, because when I equals to 1, n minus 1 minus I is going to be 0. So those 2 characters will be reversed. But I will still be missing the null terminator after that. Okay, so that will still be missing. And to fix that, you can put in a code like this. While I don't have that anymore, so we can just say reversed bracket I, because I is already incremented into that position. I just put a null terminator at that point, and that will terminate the output string of reversed. Is that okay so far? Kind of? Okay, so just to recap what I did here, this subroutine has 2 distinct phases. The first phase, which is from line 6 all the way up to line 10, is to find out exactly where original ends. How many characters are in original? That's what it does. The second part, which is from line 11 all the way up to line 18, is to say, okay, let's copy the portion in original that is in use in a reversed way into the destination, which is the reversed string or the reversed parameter. Okay, we know that it works for 2 characters. Let's see if it works for 0 characters. What if original is a null string, which means it is empty? The first character of original is a null character. So let's see what happens. So this is basically a null array. The first element is already a 0, which means when I gets a 0, the first time I get into this condition, it is already false. Okay, original bracket 0 is a 0, and as a result, not equal to 0 is a false condition. So it will get out of the loop with I being 0 at the time. So that would make n equal to 0 as well. So when I get into this part here, it will basically exit right away, because I is less than n is failing right away. I is 0, n is 0. So it doesn't even get into the loop. It won't execute line 15 nor 16. And then it will get out to line 18. By that time, I is still 0. So that means I'm just terminating a null string using a null character. And that's fine. That is what it's supposed to do. Okay. So you can do this with an actual test case and use GDB, but you have to kind of go through all of these test cases to make sure that this code will work in those two particular cases. All right, so I'm fairly confident this is going to work. So I'm gonna test the program again. G++, GDB main, list the whole thing again, put a breakpoint on line 32, same thing, same process as before. So I run the program with test5 as the input, and I can tell from the output that it is almost correct, okay? Or it looks correct to me. But this is not a good confirmation, because if it had printed any type of non-printable characters, I won't be able to see it. In other words, the program can be slightly incorrect and have some non-printable characters following the 0 on this line, and I won't be able to see it. The only way to really confirm that it does not have any trailing non-printable characters is on line 32, print it out in GDB. So we can say print output buffer, and this time I can confirm 100% that it is just 9 to 0 and followed immediately by a null terminator, to make sure that I'm not printing anything that cannot be seen on the screen when I just use cout. Are we still doing okay so far? Okay, so I will continue the program. The program does exit, but not correctly, because you can see that it is also reversing QUIT, which I said don't do, right? It's supposed to exit right away when it sees QUIT. Do not reverse the line that has QUIT on it. But that's a relatively easy thing to fix. Okay, so we'll go ahead and fix this part. Okay, it is doing that because the cout is in the loop and it is not conditional to anything. Okay, I'm going to print the reverse. The reversing is also unconditional. So it seems like line 29 and line 30 should be inside a conditional statement to basically say only want to do this sometimes. But where do we want to do that? It's going to be the same thing here, right? If I do not see QUIT and a null terminator, then go ahead and reverse it and then print out the reversed version. So I can either reuse the same condition here, or I can copying and pasting is not a good idea. So what I'll do instead is I can use another variable to say, have we seen the end yet? Is time to quit. Okay, kind of long as a variable name, but it works. And we'll do a copy and paste. But I'm going to change the other one so it's not strictly copying and pasting. So is time to quit is going to be the non-negative version of this condition, because I am looking for the word quit, because the name of the variable is saying, okay, is it time to quit? And then here, I would say if not is time to quit, then we'll do the reversing of the string and then output of the reversed version of the string. And then here, I don't need all this cumbersome stuff already, because we have done it already. So we just say, while not is time to quit, don't do the whole thing again. Okay. Is everybody kind of following the logic? How I move the condition into the do while loop, because I want to evaluate that condition before I do the reversing and then the output of the reverse portion, the reverse string. And since I have is time to quit already as a variable to indicate whether it's time to quit, I can reuse it on line 38. Yep.
Is it still comparing the C into the is time to quit? Because it looks like it's just giving time to quit.
Sorry?
Time to quit is a string, right? QUIT 0.
Oh, it's a char. It will still work. It's not a string. It is a single character, which is basically an 8-bit integer. You can kind of look at it that way. So I think the compiler will still compile this without any problem. Let me check first. Okay. Yep, it still compiles it without any problem because it is still considered an 8-bit integer. But its time to quit is supposed to be a Boolean. I think the mic just died on me. That's okay. We can you can turn it into integer. So instead of wasting 8 bits to represent something that's either a 0 or non-zero, now I'm wasting 32 bits to do the same thing. But it works the same way. Yep. So we'll go ahead and recompile the program. GDB main, run it with test5.in, and this time it does not print QUIT in reverse. That's one way to do the program. I've just given you one possible solution to write this program. Right? Question. Go ahead.
Somehow my program still freezes when I enter the input. It doesn't allow me to enter anything else. It just hangs there, and that's it. Copied exactly the same way. This is strange.
Well, I'm just trying to look at the time and determine whether I want to use the time to troubleshoot your program, because I think that is really a useful skill. No. It's fine. I just want to evaluate, whether I should talk about classes or not, as opposed to this. Tell you what, I'm going to use your program as a question in the practice final, because we'll talk about the practice final on Wednesday. Okay. Well, not specifically yours, but I would use a program that is faulty, and it does something that cannot be easily explained, and I will use it as a question, as a potential question for the final exam. Yep.
When is the final?
17.
When is the final?
17th.
That's a good
10:15 at 17 on the 17th. 10 to 24.
It's in the syllabus. I cannot remember all this stuff because I put it into the syllabus.
Wow. See? Exactly the same.
And it is. This is the morning class, so it is on the 17th from 10:15 to 12:15.
He changed it.
Oh, okay.
Did you get a chance to get our math exams?
See?
I'm missing some of the questions, so I have to ask some people to bring it back to me so I can rescan before I can continue to grade it. So if you get a message from me saying that your exam is not scanned correctly because I ran out of hard drive space, you will have to bring it back to me so I can rescan it so I can continue to grade it. Some of you got that message, okay? So check your apps account, okay? Check your Lost Reels apps account. If you do not get a message from me, you are okay, you're fine. If you got a message from me, and I think some people in this class should be getting messages from me, so you need to check and make sure that you check the message.
We only got the first exam back, right?
Correct. But the second exam, I cannot continue grading it because some of the scanned copies are
Right, I'm
faulty.
saying I don't think we got the second exam back.
The first exam. Oh, you mean the physical one?
Yeah.
Oh,
Because it makes like an exam.
Second, no, he didn't grade the second one.
That's what he's talking about.
okay.
You asked him how to know.
Yeah.
Sorry?
Is that the second? Is that the second exam right there?
If you don't get a message from me, you can keep it. Yep. If you get a message from me, that means I have to scan it again.
No, I've been wanting to see it for long.
Sorry?
Is that the second one, right?
This is the second one.
Yeah.
Yeah. If you get a message from me, then you don't want to take it. You'll just leave it in the pile so it gets back to me after I pass it to the whole class.
And the message, did you send it through the email or is it?
I sent it through Google. So if you log into Google, you should be able to see that message. But it's also going to be sent as an email message through apps.lostreels.edu. So if you go to that account, you should be able to see it too, as well.
Does that have to do something with me using code blocks instead of Linux environment?
Possibly, but code blocks should not change the logic of a program.
Mm-hmm.
So go ahead and I'll take a look at it because it seems kind
Can you
of.
pull up the source code just for a minute so I
Oh,
can
you mean
compare
my
it
source
again?
code?
Yeah, the one that you had. Yeah.
I got the message.
You got the message? Okay.
Just-
All right. So
At 2 a.m. I got the message.
Yeah. I thought you guys read your email often.
I have like 200 unread messages on my email.
Why don't you just get it forwarded?
You haven't had it forwarded yet?
No, I'm saying if you get it forwarded, it's easier. It just comes to your inbox.
Yeah.
Right?
Yep. If you don't have it forwarded, the nice thing is, you know, it doesn't get spammed because.
100 residents and scroll it down a little bit. I found one mistake. I was missing line 16.
You're missing line 16?
Was missing,
that
yeah.
will explain it.
Okay.
If you're missing line 16, that becomes an infinite loop because I will never be incremented. If it's less than n to begin with, it will always be less than n.
Now it works properly.
Okay, that's good.
All right.
That is good. We found the
problem.
answer.
We got it right
Yeah,
here already.
that's good.
Well,
Okay,
thank you.
sure. You're welcome. So we have about 5 minutes to talk about object-oriented programming. And I really kind of hate it because, you know, I ran out of time at the end of the semester. So you guys are not going to be well prepared for CISP 400. It's a trade-off, you know, I talked about other things that will still be useful, but, you know, this is supposed to be something that I need to talk about. Okay, so I'm going to try to cover, you know, object-oriented programming in 5 minutes. And I'll probably be post-produce, you know, some, you know, videos so that you guys can go with that too. Obviously, I cannot ask questions regarding, you know, object-oriented programming, but this has nothing to do with your grade in CISP 360. It has to do with your grade in CISP 400 and thereafter. So it may be something that is actually kind of important, okay? We talked about struct already in this class. In C++, in object-oriented programming, it has a different name. It is called a class, okay? There are a few major differences. I'm not going to go through all the details because of the lack of time, and you really should read through all of this after the final exam week is done because you need to do this before CISP 400. Okay, so let's talk about what is a class and why a class is different from a struct. A class is a classification. It's kind of like a cookie cutter, kind of like a struct, but it has one extra thing that it can do. A class can be related to another class using the inheritance relationship. Okay, so the example that I use here is a fly, housefly. Okay, so a particular fly that you can see, Oswald, is not a class. However, the name housefly, I looked this up in Wikipedia, so this seems to be the name for housefly. I can read a little bit here. You know, this is probably the fly, you know, classification, and this is domestic, so that makes it a housefly, right? So a housefly as a classification is basically, it is a fly. It has a superclass of, you know, musca, whatever it is pronounced, and then it goes up to another higher classification of this name. But when you look up this name in Wikipedia, it tells you that everything, all organisms that falls into this particular classification has certain properties. One of them is the antennae are 3-segmented. Okay, so we'll just focus on this one. So if you know that a housefly is, you know, part of this particular classification, without even seeing a single housefly, what do you know about a single housefly?
It's annoying.
3-segmented antennae, right? Okay. But that's the whole point of your inheritance in C++ or object-oriented programming, is you can basically say, it's kind of like saying a struct is going to copy and paste everything from another struct. Is that okay so far? So you can say a particular structure has all the same members as some other structure, but you don't have to copy and paste it. All you have to say is to refer to the other one. So that is what we call a is-a relationship. And that is also discussed a little bit, but before this part here. So a class, oh, thank you. Thank you. So basically a class has the ability to specify the is-a relationship, as opposed to a structure which only has the ability to express what is has a relationship. Now, has a relationship is a completely different thing, because when you look at a fly, okay, a fly can have what, 6 legs, right? 6 limbs. It has a relationship. But a fly is an insect. That is a relationship. So if I tell you ahead of time that all insects have 6 limbs, what do you know about a fly? It has 6 limbs, right? And you can specialize a class as much as you can, or as much as you want, by adding additional details. So every time you say, oh, this is not just a housefly, it is a special kind of housefly, and you can add a classification on top of what is already known as a housefly. Okay, so that's one aspect of object-oriented programming. And then the other one is methods. When we deal with structures, you can only have data members in a structure. Okay, we have integer, we have month, days, year, and so on and so forth. And when you want to process a structure, you have to define the subroutine kind of like this. Okay, you have to pass a pointer to the structure as a parameter if you are intending to change one of the members, using a particular way. So this is the way we perform, this is the way we treat structures. The way we do it in C++ using object-oriented programming is a little bit different. So counter in this case is the name of a class. X is a data member. So up to this point, it is the same thing as a structure. But then we can look at line 4 and below, and we can say, oh, we can do some more with object-oriented programming. Because you can actually define subroutines, which we call methods, inside the class. So in this case, reset is actually called a method, as opposed to in the struct code, reset is, or counter reset is just a normal subroutine. Are we doing okay so far with this concept? I know I'm kind of rushing here, but this is one major differentiation between what is a struct in C as opposed to what is a class in C++. So in C++, by doing it this way, you can now refer to the method by calling for the name of the variable first, and then you say which method you want to use of that particular object. Is that okay? Kind of? Okay. And then of all the members, there are 3 different types of classes, or 3 ways to hide something. Public means nothing is hidden. Private means only the definition of the same class has visibility to that particular member. Protected means somewhere in between. Okay, it's not public, and the member is only visible to this class itself as well as all subclasses. Okay, so that's those are the 3 ways to control the scoping of something. Yep.
You mentioned that we should look at this more after the final. Does that mean that you will still allow us to log into Moodle after
Yes,
the final?
absolutely. So Moodle will be up, or at least the class content, your grade and everything that you turn in, all the records will still be accessible at least up to the day that I have to turn in grades, which is probably be the 2nd or the 3rd of January. I'll probably make it, I will keep that information on as long as possible, so that you guys can basically take the notes out of it, and do whatever you need to do with it. We are running out of time. I don't really, because rushing through this stuff is not going to be very helpful. So what I'll do is I'm going to spend some time to make a YouTube video. It's not going to be a class lecture. It's just going to be me talking to the microphone, which is always fun, because at least in the class I can look at you guys and go and pretend that I'm actually talking to people. But on a YouTube, it's not going to be the same thing. I'm just I talk to the screen instead. But this is really important stuff. I don't want you guys to miss out this stuff, because you will need it in CISP 400, and I don't want you to be underprepared for CISP 400. I think some of the reason why we are kind of falling behind is, 1, I'm not scheduling my time correctly, and 2, sometimes I spend more time to kind of run a program to show you guys how to debug a program, like what I just did today. Now that is useful as well, but I'm running short on time on the other stuff that I need to go over. That's the trade-off. All right, so we'll meet one last time for lecture on Wednesday, and then after that we'll have the final exam, and for this class is on the 17th.
I made a little note of the homework that you didn't grade, so